So first, Christian Duff is the Strategic Projects Manager for Angus Australia, and his main role is overseeing Angus Australia's R&D initiatives, including the Angus Sire Benchmarking Program. He is also involved in the Pedigree Export Certification Service and the Australian Northern Development Program. Christian's also a part-time PhD candidate at the University of New England, focusing on research to further understand and improve genetics for meat quality in beef cattle. And Christian's partner today in discussing ImmuneDEX is Dr. Brad Hine. Brad is a research scientist with the Commonwealth Scientific and Industrial Research Organization, or CSIRO, in Australia. He has expertise in ruminant immunology and conducts research aimed at developing methodologies to assess immune competence phenotypes in beef cattle and developing alternatives to antibiotics to prevent and treat disease in food-producing animals. Brad has a particular interest in assessing resilience traits in livestock related to an animal's ability to cope with challenges in their production environment and how such traits can influence the health, welfare, and productivity of livestock in a changing production environment. So without further ado, we're going to hear from Brad and Christian about measuring and selecting for immune competence in Angus cattle.
So good afternoon everyone, and thanks for joining in with the discussion today. My name's Brad Hine and I'm a scientist at CSIRO here in Australia, and later on in the talk you'll hear from my colleague Christian Duff, who's the Strategic Projects Manager here at Angus Australia. So we'd just like to thank the organising committee for the opportunity to talk to you today about our work on measuring immune competence in Angus cattle here in Australia. This has been a collaborative effort between CSIRO and Angus Australia, and you can see on the title slide there a long list of people who have made really important contributions to the work along the way, so we'd just like to acknowledge them as well. So in the presentation we'll step through what is immune competence and why is it important to the beef industry, how do we actually go about assessing immune competence phenotypes, what phenotypes are available and the analysis that has been undertaken to date. Christian will tell you a bit about what exactly ImmuneDEX is, and we'll finish up with some details of what the future holds. So it's common practice for commercial producers in Australia to buy sires from their preferred seed stock suppliers, and when those producers are making selection decisions on sires, they have access to a lot of estimated breeding value data on a multitude of traits that are related to carcass, growth, reproductive performance, etc., that can help them with their selection decisions. What we haven't had up until now has been information on traits that are related to health and fitness that will allow producers to place some selection. So good afternoon everyone, and thanks for joining in with the discussion today. My name's Brad Hine and I'm a scientist at CSIRO here in Australia, and later on in the talk you'll hear from my colleague Christian Duff, who's a bit about what exactly ImmuneDEX is. I have access to a lot of estimated breeding value data on a multitude of traits that are related to carcass, growth, reproductive performance, etc., that can help them with their selection decisions. What we haven't had up until now has been information on traits that are related to health and fitness that will allow producers to place some selection emphasis on these traits in their breeding objectives. So why are health traits important to consider? We know that consumers are increasingly aware and concerned about the use of antibiotics in food producing animals. Why are people concerned? And that is because of the perceived contribution that agriculture has to the ever increasing global problem of antimicrobial resistance. So as we move forward, there will be increasing scrutiny on on the use of antibiotics in livestock as a consequence of these concerns. And certainly already we're seeing in many countries that the blanket use of antibiotics as a preventative for disease is largely stopped and will not be allowed to continue. So very important that we come up with strategies that can help with reducing our use of antibiotics. So it's very tempting to make the assumption when we think about health that the animals with the best immune system that are best able to resist disease are those animals that are the most productive animals. Those animals that are the most productive ones, you know, it's easy to make that assumption that they've got there by being resistant to disease, but there's mounting evidence out there now in many of our domesticated species that if we select hard for productivity, that we actually increase susceptibility to disease. So if there's one take-home message I'd like to give you today, that is that if you are selecting heavily for productivity, to not make the mistake that is actually selecting for disease resistance as well, because there's overwhelming evidence to suggest that is not the case. On one hand, we have the situation where if we're selecting for productivity alone, we're inadvertently increasing the susceptibility of animals to disease. While on the other hand, restrictions on our ability to use antibiotics in food-producing animals is reducing our ability to treat disease. So in some ways we can see as these things merge together that there really is a perfect storm brewing. It's really important that we get ahead of the game and have strategies in place before we get to that point. So what can we do as a beef industry? Like many industry problems, it'll require a multifactorial approach to try and address these issues. So we can think about this in terms of genetics, environment and management. So from an environmental point of view, we can look at developing strategies to reduce the environmental pathogen load that animals are exposed to in our production systems. It's also important that we're looking at developing alternatives to antibiotics that can be used to treat disease in our animals. And what we'll be talking to you about today is a genetic strategy to improve disease resistance. So this is really a longer term goal to look at the ability of genetic strategies to identify those animals better able to cope with disease in their production environment. So yeah, my message is really that industry needs to be really proactive rather than reactive. And certainly here in Australia, we've been very lucky that the Australian Lot Feeders Association are investing heavily in trying to develop strategies to improve the health and welfare of animals in their system. So genetic strategies to improve disease resistance. The good news is that we know that immune responses in cattle are heritable, and therefore we do have potential to select individuals with a better ability to resist disease. And that's been demonstrated in the livestock industries for probably over the last 50 years, where we've been very successful in breeding for resistance to specific diseases in sheep, cattle, pigs, a whole multitude of different species. And what we'll be talking to you more about today, though, is about breeding for general disease resistance. Now, this was a concept first proposed by Bruce Wilkie and Bonnie Mallard at the University of Guelph back in the 80s, and the idea here is to breed animals that have the ability to have broad-based general disease resistance rather than concentrating on any specific disease. So the early work done by Bonnie and Bruce was really in pigs, and more recently Bonnie has taken that work into dairy cattle very successfully, and some of you may have heard about the Immunity Plus CMEX bulls that are highly disease resistant that have come out of that work. So I was fortunate to do a postdoc in Bonnie's lab, and that was where my interest in breeding for general disease resistance really started. So what are we talking about when we're saying breeding for general disease resistance? So if we just think broadly, the adaptive immune response targets the way that it handles different pathogen challenges, and the immune system's very good at working out how to eliminate pathogens. Generally, it's cell-mediated immunity that handles intracellular pathogens like viruses and such, whereas antibody-mediated immunity is particularly effective at eliminating extracellular pathogens. So when we talk about breeding for general disease resistance, we're really looking to combine measures of cell-mediated and antibody-mediated immune responses in animals to try and identify those animals that are actually really good at doing both. So breeding for general disease resistance, as I just mentioned, different arms of the immune system are important for fighting different types of disease. And so there is a risk that if you select for resistance to one disease, that you can actually inadvertently increase susceptibility to other diseases in that population. And we've seen that with cattle selected for resistance to brucellosis. Although the cell-mediated immunity is particularly good in these animals, we know that inadvertently their antibody-mediated immunity is not quite as good. So breeding for general disease resistance, it's a really good strategy to combat complex diseases that are caused by multiple agents, and a really good example of that is bovine respiratory disease. These diseases are very hard to achieve 100% protection with vaccination simply because of the multitude of agents and combinations of agents that lead to disease. Also, I think as in an ever-changing climate, the animals are being exposed to new diseases. There's emerging diseases that animals are exposed to, and this type of approach is really appealing to help combat those emerging disease threats moving forward. So assessing immune competence in Australian Angus, so we've modified the methodology that was first proposed by Bonnie and Bruce back at the University of Guelph to tailor it to the Australian commercial Angus system. And a couple of modifications of note here are that we use a commercial vaccine to induce the responses we measure, and that was important for us so that we did not restrict the future sale of these animals for human consumption down the track following our testing. The other difference or modification that we've made is that we actually do our testing while the animals are under stress. We know in our production systems that we get spikes in disease incidence at those times when animals are experiencing stress, and a good example of that is feedlot induction, new environment, new diet being handled, and we get a spike in disease. So we specifically target the weaning period to do our testing, and we overlay our testing over that yard weaning period, and that allows us to test the ability of animals to mount an immune response when they're under some stress. So this is just a little quote which I think is a really pertinent one, and that is that the best immune system is not the strongest one, but rather the one that maximises fitness in light of constraints. And what that's about is it's not necessarily the animals with the strongest immune systems that we're targeting. It's those animals that can mount a good response when they're challenged with a disease threat when they're under stress. So how do we go about assessing immune competence on farm? So as I mentioned, we overlay our testing on the weaning period. So we induce immune responses by vaccinating the animals on the day of weaning. We then allow the animals to respond to that vaccine, and we come back and measure immune responses. So we take a combination of measures of antibody responses. So we collect blood from animals and look at antibody responses in blood, and we also do a skin fold test, a little bit akin to the traditional tuberculosis tests that were undertaken to look at cell-mediated immunity. And then these measures are combined together to come up with what we call our ImmuneDEX value, and that's something Christian will run you through a little bit more later. So ImmuneDEX, it's really an index that is trying to predict the ability of animals to mount an immune response when they're under stress. We expect that it will reflect broad-based disease resistance, so our target here is not any one specific disease, but rather broad-based disease resistance. And we really hope that this will provide a tool for Australian Angus producers to start to place some selection emphasis on health traits for the first time. So I just thought I'd present some raw data here, looking at some of the measures we've collected that contribute to that ImmuneDEX value, really just to demonstrate how much variability exists within a given herd and a given contemporary group of animals. So the top graph is just weaning weight, which is a traditional measured trait here in Australia, and on the bottom on the left is our measures of cell-mediated immunity. On the right are measures of antibody-mediated immunity. So the bottom axis, the numbers refer to a herd and the letters refer to a year drop at that location, at that property. But what's really important here to see, I think, is that there is an enormous spread in responses within a given herd on a given farm within a given year. So that tells us that there's lots of potential to actually select animals that have an enhanced ability to mount immune responses. We're quite surprised by the amount of variation that actually exists in the population already. Once we had immune competence tested animals as part of the Angus sire benchmarking program, and Christian will talk a little bit more about those animals in a moment, we're able to follow these animals, a cohort of about 980 steers, through feedlot finishing at a commercial feedlot to actually monitor our ability to actually predict health outcomes at the feedlot. So these animals were categorised as high, average or low immune competence animals. So to be a high animal, you have to be able to mount a good cell-mediated and antibody-mediated response, and vice versa. To be a low animal, that animal's not very good at mounting either a cell or antibody-mediated response, and the remaining animals fall into that average category. We were able to follow these animals through the feedlot finishing process, collect really detailed data on pull rates from pens, how animals were treated and what sort of drugs they were treated with, etc., the cost of those drugs, and cost of animals coming into the feedlot at the start, cost of feed per day. And from all of that, we were able to generate a cost related to health for these animals at the feedlot. So for high immune competence animals, the average cost was $3.53 per animal. For average, it was around $28, and for the low animals, it was around $103. So that's health-related costs per head of animals that entered the feedlot. So what was really interesting for us was that although only around 11% of animals we classified as low immune competence animals, they actually contributed to around 35% of the total health costs that were associated with that cohort of animals. So this was really encouraging. We will continue to work now to perform more validation studies on bigger cohorts of animals in commercial settings, and that's really where we're at. So I'll leave it there and I'll pass it over to Christian to take you through the second half of the talk. Thank you.
Thanks, Brad. Good afternoon, everyone. I'm going to take you through the second half of this presentation, which is about where we currently sit with immune competence at Angus Australia in regards to what data we've collected using the methodology Brad outlined for immune competence, and how we've analysed that data to produce some sire information and what the next steps are. So to start with, where we're at in regards to recording phenotypes for this particular trait, the immune competence traits, we've currently gathered and analysed immune competence phenotypes on over 3,000 Angus steers and heifers at weaning, and that's from our Angus sire benchmarking program, which is our large progeny test and reference population program we run at Angus Australia, which has been running for 10 years now. We've currently got, out of those particular phenotypes that got recorded and analysed, we're recording them from certain cohorts. We sort of recorded some in the early days. We did a bit of work on those in cohorts 2 and 3, which is back in 2012 and 13. And then we have just increased our recording as well based on calves born in 2016 and 17 and going forward from there. So we've currently got 165 sires with progeny represented with these phenotypes as well, which we've used in the analysis. So we've used that information, and all these calves they've got other things other than immune competence recorded. They've got all the other performance traits from birth through to slaughter in the steers and birth through to first calving in the heifers. And we've also importantly got genotypes recorded on those as well for our genomics reference and analysis. So basically what we've done is we've created some research breeding values on these, which I'll take you through more now. And we actually released a list of sires with research breeding values for ImmuneDEX, and I'll explain that more in this presentation, and released that in May of last year. So it's a very new analysis, released for the first time in last year worldwide in the beef industry, which we're very excited about, but it's a first step. We've got a fair bit more work to do in this space as well. This is what the report looked like. So this is the Angus ImmuneDEX report, the research breeding values, and again I'll take you through this in more detail and let you know where you can access that information if you're interested as well. So in regards to those phenotypes I explained, we had antibody-mediated and cell-mediated immune competence phenotypes on those 3,000 Angus steers and heifers at weaning. We created some heritabilities on those, and that was done through our friends at CSIRO as well and their genomics team. And once we crunched the heritabilities of those, the pleasing thing was they're heritable. So first of all, we knew we can do something with them genetically if we want to make some selection decisions. So antibody mediated response was 0.23 heritability, and cell mediated was 0.28. So they're moderate heritabilities. They're similar to our weight traits, for example, our weaning and yearling weights in our Australian analysis. So we know if we want to select on these traits and make a change, we can. Importantly, we've also done some little bit of work on correlations. These are not pure genetic correlations, I should say. They're correlations between the breeding values for the immune competence traits and production traits. But in general, what we've found is that there is a weak negative correlation with some of the production traits, particularly the weight traits like yearling weight, carcass weight, eye muscle area. So it looks like there is a slight negative correlation, which sort of fits in with the other species around the world, that if you select purely for performance, then your immune competence could go the other way on a genetic level. We've also found there's a weak but favourable correlation with the temperament traits, so things like docility score, flight time particularly. As you'd expect, those animals that stress less probably have better immune systems phenotypically, but also on a genetic selection level. I should add they are currently weak correlations that we're seeing, so we need to do much more analysis in this space to see if those correlations change, but that's how they're looking at this stage. And that's shown in this correlation matrix, and it's a heat map. So basically anywhere there's a red bit on the map, that means there's a positive correlation towards one. The more green the bit on the map, the more negative the correlation is. As you can see there, when the traits line up with one another in the matrix, they've got a correlation of 1, as you expect. Importantly, when you look at, say, ImmuneDEX, and that's what those values are down on the right-hand side there, the correlation with the ImmuneDEX value we've created, you can see there that there is a slightly more negative correlation with some of our weight traits like carcass weight, final weight, yearling weight, etc. And obviously you can then see also how the different immune competence traits fits into ImmuneDEX. Both of them are quite positively correlated in the ImmuneDEX value, which I'll take you through more in a minute. So that's what we're seeing at this stage in regards to the traits. Luckily, we're not seeing really strong correlations, because obviously if we had very strong correlations with some of our production traits, that makes it a bit hard to select for these things at the same time, immune competence with our production traits. But there's correlations there, but they're weak, so that's a good thing in regards to selection. Particularly if we're trying to drive these things in the same direction. Highly productive animals genetically that also have strong immune systems genetically. If you want to know more about the correlations and the heritabilities and how they were calculated, and about the phenotyping as well, there's been a paper published in October last year in the Journal of Animal Science. So I've got that up on the screen there for you. I encourage you to go and have a look at that paper and find out more. It's all very well documented in that particular scientific paper. Now, in regards to the ImmuneDEX value, just to explain that in more detail, first of all, ImmuneDEX is purely based on genomic relationships, so we haven't used any pedigree in this analysis. We've used our genotypes coupled with our phenotypes for the particular traits, and that's the way it was calculated, again outlined in that paper I showed before. Selection indexes looks to optimally combine the antibody and cell-mediated components of ImmuneDEX. So what that allows us to do is select for those two things at the same time. As Brad pointed out in his presentation, it's important we look at both streams of those responses. So the ImmuneDEX value is set up to optimally look at pushing those two things in a favourable direction when we're selecting on those. And I'll show you a paper next which outlines that methodology a bit more. So the ImmuneDEX value, what it does is it provides an estimate of a genetic difference between animals for overall immune competence, which is a key component of resilience. And in regards to the ImmuneDEX, if you're looking to select animals that will give you lower disease resistance in the progeny and particularly a high proportion of progeny with stronger immune systems, then you'd be looking for a higher ImmuneDEX value. Now the ImmuneDEX value, I can't give you a traits like we do in birth weight, for example, in kilos or eye muscle area in square centimetres in Australia. It's basically just an index unit, so that's something we'll also be looking to the future. Can we put it in some sort of unit basis on health outcomes? But at this stage it's just a selection index unit, basic unit as such. This is the paper I referred to, which shows and explains the method we used for creating the ImmuneDEX value, and it was available at the AAABG conference and presented there last year, so it's a conference paper. Again, I encourage you to get on and have a read of that if you want to know more about how we came up with the ImmuneDEX selection index basis. And that explains that in good detail. So what are the research breeding values saying for our immune competence? This is a list, and this is actually, I think, the top 25 bulls that were released. As you can see there, we've got the IDs of the bulls, the top bull being Paringa Red Pilbara K146, which particular cohort he was entered in the SIRE benchmarking program, and his research breeding value for ImmuneDEX, you can see it's plus 70, the accuracy at 92%, and how many progeny they've had analysed in the analysis. So Paringa Red Pilbara has had 20 progeny that's been immune competence tested through the SIRE benchmarking program. When using this is some of the advice we give to breeders. Obviously it's a research breeding value to start with, so you've got to be a bit cautious. Obviously, as more data gets added and we enhance the models and look at things at different angles, obviously these things can change. But for those breeders that are really interested in this space and want to get on the front foot early and do some selection, there's information there now to do it. The good thing is there's significant range across the bulls. For the ImmuneDEX values, they range from 0 to plus 70. So if people want to incorporate those in their breeding programs, they can. Obviously, we do suggest a bit of caution at this stage because it's still early days. But the information's out there for people to start thinking about it, and that's the important part. How do we think about building in some welfare and health type traits into our breeding objectives, if that wants to be done both now and in the future? Obviously, there's a limitation at this stage about using what bulls we have available. They're all from the Angus SIRE benchmarking program at the moment. There's about 165 bulls in the list at the moment, so that obviously limits the bulls available to select on. However, a lot of those bulls are recent bulls, current bulls, and we are looking at methods to update these ImmuneDEX values going forward. Just about the variation we see in the correlation side of things, this is just, again, just looking at a correlation between our ImmuneDEX values on the x-axis and those bulls' Angus breeding index, which is our overall selection index, dollar index with economic weightings in it, in the Angus breed in Australia. And each of those dots represent a sire that we've got those two values available for. Now, as you can see, it's a fairly shotgun approach. There's not a great relationship between those two things at the moment, which is a good thing in regards to selection. So, again, if you wanted to select high ABI bulls, you can still find ImmuneDEX animals that are high in ImmuneDEX as well. So that's a good thing in regards to selection. But things could develop as we go forward as well. We need to keep an eye on there. So where to find the ImmuneDEX RBVs? They're on the Angus Australia website. So if you go to the research menu item, and then you can see there's an item there that comes up as ImmuneDEX. You click on that and it'll bring up the ImmuneDEX report that anyone can print out and have a look at. We're also just developing a system where it's going to be available on our online search facility, along with a range of other research breeding values in a special location, which we'll promote to industry soon. So that's another thing under development, so people can access it not just in a PDF report, but also in their normal searching and sorting on the Angus database search facility. So what does the future hold for ImmuneDEX? Well, first of all, we're going to continue collecting our immune competence phenotypes as part of the Angus SIRE benchmarking program in collaboration with CSIRO. Basically to develop more research breeding values on more sires and obviously improve the accuracy of the breeding value as well. And our aim is to, in the next, by the end of next year, 2021, is to have over 5,000 Angus animals with genotypes and immune competence phenotypes collected. And we're on track to do that. In the shorter term, what we're looking to do is update the ImmuneDEX research breeding value sire list based on about another 1,000 phenotypes we've got from cohorts 8 and 9 of our Angus SIRE benchmarking program. So we'll look to update the report in the second half of this year with that information included, which is obviously a good step. The other thing that Brad's also mentioned that's happening in conjunction or in parallel with this is SIRE and MLA have a project going where they're looking to further examine the benefits of selecting for immune competence in standard commercial feedlot environments. So particularly linking up, if you do select for this trait, high or low, what are the outcomes in feedlot environments in regards to disease that they see commonly in those particular environments. So that's obviously an important part of this process, to be able to link those things up to provide more information back on, if you do select on this research breeding value, which we know you can change genetically, what are going to be the outcomes in the progeny going onto feed, for example. Obviously, another important part of this process then is to also develop a pipeline for regularly delivering research breeding values back to industry. So what we're looking to do at Angus Australia, set up a pipeline. So any animals that's genomically tested with a high density panel of 5,000 SNPs or more, we'll look to then also provide a research breeding value for ImmuneDEX back on all those animals that have been tested. Again, to broaden the number of animals we have available with this information based off their genomics and the reference population phenotypes, to let people start thinking about this particular trait in their own herds, in their own situations. And obviously with more animals with information available, that helps selection because you've got more animals to select from. So that's the next steps in the future for ImmuneDEX. So with that, that's the presentation finished, but we need to acknowledge there's a range of people involved in this. As we've explained, CSIRO and Angus Australia have been working for a long time on this project together, and it's working really well and will continue to do so. But we can't do this without co-funding, particularly from MLA and Alpha, who are our peak body representatives in Australia. They look after the research funding for beef, both in the grass-fed and feedlots environments. We obviously have to pay a lot of credence to our cooperator herds that allow us to go on farm and test their weaners. It's quite disruptive, so we obviously have to thank them for allowing us to do it and do the testing, the bleeding, the measuring on those cattle. Obviously there's a range of Angus Australia and CSIRO staff involved as well, including the GX team to do the crunching at CSIRO and also the technical staff on the ground. So we must acknowledge all those people involved, and we look forward to seeing where this trait's going to go in the future. That's for sure. So thanks for your time.
All right. Well. Well, thank you very much for that. Some really interesting information, and I see you both up on the screen here. So, hello. I have no camera, but I'm waving. We'll maybe go through a few questions in the chat box, if that's okay.
Sure.
First is, what is the reliability of your validation reliability of genomic breeding values?
Yeah, it's a good question. It's probably a bit bigger than our research area, but look, going back to our talk, these breeding values and if we presented were based on genomic relationships. We didn't use pedigree in this particular analysis. So we're comfortable as Angus Australia that the genomic breeding values in this context will give us reliable breeding values, and I think there's plenty of information available that in other research areas that would indicate that. So this area of research wasn't specifically looking at the overall reliability of genomic breeding values. We're comfortable that it's the way to go in this case, because the reason we went that way is because all animals' phenotypes also had a genotype. We didn't have a mix of animals that only had a pedigree or only had a genotype, so we went down the genomic breeding value path in this case. I'm not sure if I answered that, Megan, but I'll stick to that answer.
Sounds good. We'll have questions rolling in, and we've got some time, so I'll just start kind of feeding some more to you. Do you have feedlot health data looking at the relationship between Kydex value and mortality or morbidity rate?
Yeah, so thanks, Megan. And yeah, we do have that data on around around 1,000 animals that we had immune competence phenotyped and followed through feedlot finishing. So what we saw there was the mortality rates, and these are health-related mortalities in those low immune competence animals, was around 6%. In the average immune competence animals, it was around 1.5%, and we actually didn't have any of our high immune competence animals that died from health-related illness. That was only in 1,000 animals, and we're certainly working now to validate those findings, and that's really key to moving this work forward, is for us to do more work in commercial feedlot settings to actually demonstrate that the relationship between our immune competence, phenotypes and health outcomes at the feedlot. What was interesting in that initial study is that what we found is that the incidence, the high immune responder animals did get sick, but the encouraging thing was they recovered from those health-related issues and returned back to the feedlot pen. So, but certainly we have a lot more work to do to validate these findings, and that's really where the work's at the moment to do more work in that area.
Interesting. Thank you. So looks like our next question is, I understood you to say that more docile animals tend to have better immune systems. Do you think there might be a point of diminishing return on docility and survival, be it immune response and or calf vigor, and thus calf survival?
Yeah, good question. In relation to the genetic correlation, I guess we were just looking at the correlation between the breeding values at this point in time, but what it's indicating is there is a favourable relationship between docility and immune competence. So those animals that genetically are more docile through a range of measures, flight time or temperament scoring, will also have higher ImmuneDEX values or immune competence values. So that's what it's indicating this stage, which sort of makes sense. Animals that are sort of better immune systems, less stress through their temperament, have a better ability genetically to also mount a resistance to diseases. In regards to selecting for those, I guess you have to be careful about single trait selecting and selecting too far anyway. I know in cattle in Australia, we're still got a long way to select. In all breeds, there's a big range in docility and temperament, so we don't have any concerns that selecting is going too far or could go too far in the definitely short to medium term to cause any survival issues. And I guess we need to make those links anyway on a research level. In regards to immune competence, it's something we have to think a bit more about because, and Brad might add to this, there could be issues if you select purely on immune competence and you had animals that had really strong immune systems, and where would that leave them with issues with more immune-related diseases, I guess you would say, in their systems. Do you want to add to that, Brad? Because I know you've got some thinking about it.
Yeah, so that's a question we often get is, can we push them too far down the immune competence track? And I guess we don't know at this stage, but certainly from the research we've done, we find that animals that are high responders, as an example, if you think about responses to a vaccination, those high immune responder animals tend to just reach a protection level quicker than the other animals. We don't tend to see that they continue to be hyperimmune, if you like. I think the immune system is very good at working out what it needs to do to achieve a level of protection. And so, of course, it's always a risk if we push very hard for the trait. But I think the evidence suggests that, as long as we're using immune competence in some sort of selection index with other important key traits and just putting some selection emphasis on it, I think is the key here moving forward. We sort of don't expect producers to be, placing all of their selection emphasis on immune competence, of course, just a portion of it. So yeah, I think for me, the key here is, rather than actually selecting animals, targeting those animals, particularly that are high immune competence animals, I think the key here is to actually remove the low immune competence animals out of the system. I know in the end you're actually just achieving the same thing, you're moving the average of the herd, but it's those low immune competence animals that we think cause us issues. They're the animals that don't respond to vaccination, and as you see from that preliminary data we have, they're the animals that seem to be causing the majority of our health costs in the system. So to us, if we can remove the low responders from the system, I think is probably the way to go.
Okay, looks like our next question has to do with testing the bulls and mentioning heritability in their progeny. I assume testing the bulls would be much more accurate for heritability in their progeny.
To explain a bit further, at this stage, what we've done is we've measured these phenotypes on steer and heifer progeny in our Angus side benchmarking program. So no bulls were tested themselves. We obviously produced a bull list with the breeding values in based on their progeny details. If we measured bulls, what the heritability would be, we definitely couldn't say it would be more accurate or higher heritability. We wouldn't know that. We'd have to test bulls and see. But what we've done here is we've measured animals that are in the commercial system, which I think is an important thing. So measuring animals that are going through the commercial system. So we can also link that to health outcomes in feedlots and things like that, in the steer progeny particularly. So that's why we've taken that approach, and I think we're getting that's a good approach to take for this particular trait. Measuring bulls, yes, there would be some options to do that through our seed stock and our members in Angus Australia, but we've taken this approach because it's a high value trait. It's a hard to measure trait. You need some skills like a siro to do it. Definitely not everyone can do this, so that's why we focus on our progeny test program and record those on steers and heifers rather than bull progeny.
All right, got a couple more questions. How applicable do you expect your results to be against the US Angus population?
Good question. That's a research question for the future, and I think we're lining things up pretty well to look at that through a couple of aspects. One is you probably saw in our in this bull listing as the slide came up, we do have some direct US size in our progeny test program. So we've got progeny measured in Australia on their direct progeny, GR Profit, 10X, a few others. Plus a lot of the Australian bred bulls in the program also are by American size. So we're going to have good genetic relationships to the American population. I'm confident about that. The second thing is, though, there is American Angus are doing some testing, I believe, through a program over there with Bonnie and a few others. Not using probably exactly the same methodology, but similar enough. And at the stage where there is enough phenotypes from the American population, and we're continuing to collect them, we'll look to do a joint research in that area as well, and that'll help us determine, do bulls re-rank from America to Australia for this particular trait. If we combine it together, which is good for this thing because it's hard to measure, so getting the phenotypes is not as quick as, say, birth weight or weaning weight in industry. So we combine that data set, makes sense. That's something we're discussing regularly with American Angus, that's for sure. So hopefully we can answer that question not too far down the track in a bit more detail.
Great. So it looks like someone has a follow-up question related to the mortality data that you presented, and they're interested in knowing what percentage of the mortality could be attributed to respiratory diseases.
Yeah, so in that data set, we do have details there. From memory, I'd have to go back and have a look, but about 20% of certainly the animals that were pulled from pens were for respiratory disease. Probably not as high as what you would normally expect, and that's partly because certainly the benchmarking calves, when they go through feedlot finishing, they're pre-vaccinated for BRD before they go to the feedlot. They probably don't, they're well prepared, they've been well handled, yard weaned, so they're ideal animals heading into the feedlot. So our work currently is on more commercial animals going into very standard feedlot environments in Australia, and that's certainly one of the questions we're very interested in, is whether we can see a reduction in BRD incidence in those high responder animals. So yes, there was some respiratory disease in those mortalities, but the mortalities were quite low in that study, and only 1,000 animals. So it's something that we certainly need to validate with bigger data sets moving forward.
Okay. I'm going to paraphrase the next question a little bit, and I hope I get it right. So would you speculate that the increased immune system or immune response or competence in docile cattle presents itself more due to working with people, or would you expect to see the same type of advantage if the animals were more in range conditions and undisturbed?
Yeah, that's a good question as well. I guess the work we're focusing on here at the moment in Australia is the relationship between animals under stress, particularly through the weaning period, in the relationship to feedlot outcomes in relation to their disease response, because that's obviously, there's issues there we need to address going forward, and Brad outlined a lot of those. And I'm assuming there's similar issues in America as well. In regards to disease outcomes in the field and in more range conditions, that's an area of research we need to do more work in, because there is some disease issues in Australia that are not related to the feedlot, they're related to field situations. Like a common issue that gets raised in Australia is pink eye in temperate cattle, in Taurus cattle, and regularly coming up from breeders is, which is a range condition, a field condition. If you select on high immune competence cattle, does that reduce incidence of pink eye? We don't have the answer to that yet, but we're always thinking about how do we get the phenotypes to prove that up. And that could be the case for any disease, and that's the beauty of this trait, because it's looking at broad-based disease resistance, so it should hopefully help address a few diseases along the way, not necessarily just BRD where the focus is at the moment. Brad?
Yeah, so certainly we've concentrated on feedlot, looking at disease incidence at the feedlot this stage, but obviously looking at animals on pastures, definitely important for us as well. I can tell you a little bit about, we have done a lot of immune competence work in sheep as well, and definitely in pasture-based systems there, we've seen some real benefits for selection for immune competence. So we see favourable genetic correlations with diseases in the field. This is with sheep, of course, with things like fly strike, internal parasite resistance, and general health, you know, through their productive life. So we're hoping that will translate into beef cattle as well. But at this stage, we've certainly concentrated on the feedlot side of the equation. But as Christian mentioned, as we're aiming for sort of general disease resistance, that'll translate into pasture-based systems as well. But that's yet for us to determine.
I think we have one final question in the Q&A box here, and that is, what is the genetic correlation between the antibody and cell-mediated immunocompetencies?
So yeah, they're favourably genetically correlated, but that correlation's quite weak. And that was a little surprising to us. The work that's been done in dairy cattle to date would suggest that they're actually negatively genetically correlated in dairy cattle. Certainly our work in Angus shows they're favourably genetically correlated, but that's not strong. So you may ask, well, why don't we just look at one parameter and not the other? But I think it's really risky to do that, in that if we think from a biological perspective, we're really trying to identify those animals that can mount a strong antibody and cell-mediated response. So we're very hesitant to start to just look at one particular arm of that immune system. That's what the whole immune competence story is really around. It's trying to get identify those animals with a really robust immune system that can handle a variety of disease challenges. So it's good news that they're favourably correlated. Will certainly help us along the way, but we still think it's really important that we concentrate on measuring both those traits, and we're certainly not, planning to stop at just looking at these traits. We are doing research with a lot of other parameters, and with the potential to bring other measures in, things that we can measure easily on animals that can help improve our ability to predict health outcomes with the ImmuneDEX values are something we continue to working on. So it is a work in progress, and we'll continue to look at other measures along the way that could be incorporated into that index potentially in the future.
It's also worthwhile referring again to the paper in the Journal of Science about this. So if you want more specific genetic correlation values and heritabilities and things that we've provided today, then go to that paper, and that outlines all that in a lot more detail that we can provide you today, of course.
All right, great. Well, I think we've addressed all the questions in the chat and the Q&A. So I would just like to thank you guys again for putting together such interesting information to share with us today and for taking the time to join us.
The state of Iowa and Iowa State University are proud to host the 2021 Beef Improvement Federation Annual Research Symposium and Convention. The convention will be located in downtown Des Moines with easy access to the airport, hotels, and local restaurants. Iowa State University is just north with its research and teaching farms. Join us in Iowa and experience how Iowa provides the beef industry with innovation to application.